So let's talk from Munjae Park from National University. And the title is Fluids in the Mantle Xenoliths related to multiple metasomatism from the Rio Grande Rift in Mexico.
Thank you. Yeah, good afternoon, everybody. Today I'm going to introduce the fluid in the mantle xenoliths related to the multiple metasomatism from the Rio Grande Rift in New Mexico in USA. My topic is also related to the Federal slab, which can release the fluid when the mantle xenoliths is formed. So this picture shows fluid inclusion in the mantle xenoliths, especially in the clinopyroxene. And this one of the largest size of fluid inclusion indicate 10 micrometer. And you can see when you hit this fluid inclusion, you can see the dancing bubble in the side. And some people say this kind of a dancing bubble, say crazy bubble, because like dancing like crazy. So, so this is a really interesting topic to see the fluid to the geochemical implication. So these are content when what I present. At the beginning, I want to show why we should study fluid inclusion, and then I'm going to show the study area and the previous study in the Rio Grande Rift, and I'm going to show what kind of sample we analyze, and then I'm going to show fluid inclusion petrography and microsometry, and Raman spectroscopy and FIB-SEM technique. And then I'm going to talk about the evolution of fluid in the mantle xenoliths. So, mantle dry fluid inclusion can provide significant information on chemical and physical condition in the upper mantle. And it also plays important role in understanding the fluid-log interaction. And it's also related with mantle metasomatism associated with the shallow subduction process. And the Rio Grande Rift in New Mexico, USA is also an excellent place to study the geochemical evolution of a subcontinental isospheric mantle to better understand its temporal and spatial heterogeneity. However, mantle fluid in their interaction with mantle wall log from this region was not studied yet. So it is important to know how the fluid inclusion shows in this area and from the spinet peridot from this area. So these small pictures, see that this North America, and you can see this is a satellite image from the NASA. You can see the Rio Grande Rift, which is located between Colorado Plateau and Great Plain. And this Rio Grande Rift is Cenozoic continental rift system. And we collected sample from the 3 locality, which shows white boxes. And these localities are Adams Diggings and Kilbonal and the Elephant Butte. So this sample is localized alkaline basalt magma brought mantle xenoliths to the surface during the late lifting this age. And there is some report, multiple mantle metasomatic event subsequent to melt extraction related to subducting Federal slab. So, and previously, and we found C-type LPO from here and A-type LPO from here. So we are interested in how can be different in the geochemically in the fluid inclusion system. And this picture is showing the schematic illustration in the Venice Rio Grande Rift based on the P and S wave tomography. You can see this these kind of arrow. It indicate mantle flow, and you can see that from the Federal slab, and there are there are a lot of volatile fluids released from this area, which indicated Adams digging area. So it's an interesting place to study. So, and one of the things I already present to poster yesterday. Maybe we have also time today. We can discuss if you somebody interested in this topic. So I'm going to show the sample. We collect 5 spinel from the Kilbomo and Elephant Butte area, which shows the protogranular and pupilloclastic texture. And we also collect 2 spinel and 3 Hatchwozite from the Adams diggings. And it shows the pupilloclastic texture. You can see it here, pupilloclastic texture. And it also contains the pyroxene and olivine and clinopyroxene. And you can also see the oriented melt pocket. And the interesting is we found the fluorite, which is a hydrous mineral, especially in the Adams digging sample. You can see it here, fluorite and olivine OPX. So at the beginning, we consider the how fluid inclusion, and depending on the sample locality. And we conclude that from the Adams digging sample, which shows a fluid-rich condition, which you can see here. There are a lot of fluids in the OPX, and you can also see the spinel inclusion. But mantle xenoliths from the Kilbomo and Elephant Butte shows a fluid-poor condition. So we just focus on this area of the sample to see the fluid inclusion. So at the beginning, you can see in this picture, both picture, usually fluid inclusion is trapped in the only also pyroxene, and the other mineral is really rare. So at the beginning, we distinguish type 1 and type 2 fluid inclusion, which is primary inclusion and secondary inclusion. You can see that this picture, this black circle indicating primary inclusion, and this small fluid inclusion indicating secondary inclusion. You can see that there is a crack, which related to maybe fracture, and each indicating the secondary. So we are interested in more primary inclusion. So finally, we distinguish 3 kinds of fluid inclusion assemblage based on the fluid inclusion petrography. So one of them is type 1A fluid inclusion, which shows there is a healed fracture related to large crystal size 10 to 25 micron, and it shows negative crystal shape which contain the liquid and vapor and solid phases. And it's also related to secondary fluid inclusion. And the other thing is type C fluid inclusion, this one. You can see the contained opaque solid mineral, and it's less smaller and negative shape, 5 to 10 micron. And it shows only liquid phases with a solid, opaque solid. And the other thing is type 1B fluid inclusion, which related with absorbed spinel inclusion. And this shows a spherical shape and 5 to 10 micron. You can see it here, fluid inclusion with spinel. Here, this is spinel inclusion, and this is fluid inclusion, which shows liquid, and this also fluid inclusion shows liquid. So we conducted microsomatic measurement from this range, and to observe the phase transition. So we detected the melting temperature from the order of fluid inclusion shows similar, such like -58.2 to -56.8, and which indicated the CO2 dominant phases in the with other minor component. And we determined the homogenization temperature, which we can see the changing from the both of phases to change in one phases. So you can see it in the picture. This is frequency and this is homogenization temperature. You can see the big difference between the type 1A and type 1B and C. this type 1A fluid inclusion of homogeneous temperature show more higher than type 1B and type 1C, which indicated this fluid inclusion have a more high density fluid inclusion. And we determine the density using the homogenization temperature, and we can calculate the fluid trapping pressure. You can see it here, and type 1B and type C showing around this kilobar, 8.6 to 9.6, and this is more shallow because it's related to hill fracture. And we analyze Raman spectroscopy to determine the more precise information, what kind of fluid can be trapped with CO2. So we are, as I told you, we are interested in type 1A fluid inclusion, which primary, and we found that type 1 fluid inclusion shows the CO2 fix with magnesite. And we analyze type 1A fluid inclusion here. We analyze here, and we find the fix which indicating the dissolved H2 in the CO2 with hydrous mineral fluorpite. And the type 1C and type 1B, we found some nitrogen. You can see it here with this red peaks show indicating nitrogen peak in the fluid, but the blue peaks show the nitrogen in the air. So you can distinguish using the high resolution Raman analysis. And also we found sulfur-bearing solid phases, which you can see here. We analyzed here. We detected sulfur and with the CO2. And we analyzed focus ion beam scanning electron microscopy to observe inside of fluid inclusion. So this kind of technique, you can see the sub-micron size of solid phase inside of fluid inclusion. So at the beginning, we needed to cover the platinum strip on the sample, which is located in the fluid inclusion, and we needed to make a trenching both side and the front side. And when we approach the fluid inclusion, you can see the more dark color, because this is backscattered electron image. You can distinguish it almost reach the fluid inclusion. So, and then we can see the more high magnification picture using the SEM. So these are showing the solid mineral inside of fluid inclusion. This left picture shows the type 1A fluid inclusion, which contained calcium sulfate and iron oxide and magnesium carbonate with glass thin film. With there is also amphibole. And the other fluid inclusion, which is type 1B and type 1C, we detected iron nickel copper sulfide, and there are a lot of vesicles on the wall, and but there is no glass film in the inside of here. So I want to talk about how the evolution of fluid inclusion in the mantle generators occur during the ascending process. So we can think about it, the possibility. Usually, I told you the fluid inclusion usually trapped in the OPX. OPX can contain this kind of chemical composition with extra calcium. So type 1A shows CO2 and H2 and an H2S system is possible. So we detect many solid phases, and this kind of this OPX and CO2 fluid can make magnesite with quartz, and also calcium sulfate can react by calcium from OPX and H2S from fluid, and also iron oxide and reacted with remnant of iron from the OPX. And also amphibole can reacted by the H2O from fluid and silicate. And the other type 1B, 1C shows CO2 and nitrogen and maybe silicate and the sulfide melt system. So we can think about two possibilities. One thing is MSS. MSS is monosulfide solid solution, which when the fluid with this MSS solution is trapped with inside the fluid inclusion, and during the cooling, the temperature reaching, it shows like this, and then when the mantle general is ascending and the temperature is reaching this temperature, and chalcopyrite and nickel copper rich and iron rich solution can crystallization inside the fluid inclusion. And also this temperature, you can see the pentundulate in the pyrite. So we observe this kind of texture using the FIV and SEM. But the other possibility is accidentally trapped with the fluid inclusion sulfide. But in this case, it's really rare, and it should be separated, fluid and sulfide mineral. But we shows it's connected altogether. So these are summary. We found 2 or 3 kind of fluid inclusion assemblies, which shows type 1A CO2H2O fluid with this kind of mineral and thin glass film. And type 1B and 1C shows CO2 and nitrogen fluid with sulfide faces and vesicle on the wall of fluid inclusion. And we can conclude that this kind of distribution and the composition of mantle fluid preserve as 2 or 3 fluid invasion event in the advanced digging periodicite in the Rio Grande rift. And these results are consistent with geochemical study, especially multiple metasomatism, this paper. And this dominant fluid system clarify the complexity of mantle fluids and high probability of metasomatic mantle alteration. So thank you for your attention.
Okay, thanks a lot for the nice talk to be in time. So other questions?
How high pressure did you go up to?
Pardon?
How high pressure did you go up to?
High pressure?
Which pressure do you use in the
TPA.
experiments?
No. I didn't do experiment. Yeah, I used the natural sample and
Okay, what question there? Please.
My question is,
Yeah, just loud.
Next perspective research. Do you have, what would you like to do next? You finished just simple description. What the next?
actually, in this area, there are many reports which shows mantle metasomatism.
I know.
But there is there is no result. What kind of fluids affect?
That's fine.
Yeah.
So my question, for example, how about the isotope, nitrogen, carbon?
Yeah.
Not deuterium, but also tritium, and also oxygen. All kind of such kind of elements, and the isotope may help you very much.
Yeah.
So that you should ask him to bring world top class mass spectrum.
Thank you.
Okay, thanks a lot. So, the last Kenji, where is Kenji? The last talk?
No.
Ah, the book. I'm sorry. Tutor. Yeah. Where is the computer? So, 2 more talks. So, there is now Shiwo Wu, and the title is Discussion on the Tectonic Partition of the Philippine Sea Plate.
Please, anyone? Good. Maybe the new one, the master.
Okay.